Now we're going to look at the formulas for area that we're going to have to learn. If you look at the very front of your packet, there's a whole list of formulas for this test. Some of these are given on the test, but most of them are not. And I didn't just randomly choose these. These are the formulas that the praxis says you could be asked about, that they would expect you to know. And I realize that some of you have already passed the praxis, but not all of us have, and I can only go by what they say. I don't know if you are asked specifically about these formulas, but they do say you are expected to know them. So for area, over here, you have to learn these formulas. You know most of them already, like a square and a rectangle and a triangle. Most people remember circle, and I'm going to help you understand what the parallelogram and the trapezoid are. Really, the trapezoid is the only one that you're going to have to maybe put some work into. If you need to make flashcards, then this would be the time to do it to help memorize those. So let's look at what these formulas kind of mean. So first we have our rectangle, and we know the area of a rectangle is length times width. So we say that the area is the length times the width. The reason that it is that, though, is we actually break this up into units, our square units. So I can imagine breaking this up. We did this when we were studying fractions in our Math 201 class. This is the area model. We would say this is 1, 2, 3, 4, 5, 6, 7, 8. So we could use this with our multiplication, or we could color in one square and call it 1/8. So it literally is how many squares are in this shape. So length times width. Parallelogram, you might think, oh my goodness, I don't know this one, but it's the same as a rectangle. In fact, a parallelogram is just kind of like a squished rectangle or like a slanty one. So its area is base times height, or you could think about as length times width. So imagine taking this parallelogram and straightening it up. So making it so that our line came straight down here. This is the height. So this down here is the height. The slant is not the height. So imagine cutting a line right here, taking this piece and putting it right here, and it would fit perfectly. So then if you look just from my highlighted idea, the part that I drew, you have a rectangle. So that's why the area is still just length times width. We call it something different. We call this the height and this the base, but it's still the same idea because we have conservation of area. If I had a parallelogram on a piece of paper, I could cut off this triangle and it would fit perfect there and make a rectangle. Next, we have our triangle. This is one that a lot of people remember. We have to do lots with triangles. The area is 1/2 the base times the height. So 1/2 b times h here. That's because a triangle is half, I know it's not going to be a perfect rectangle, but it's half of a rectangle. We just said we could say base times height. Well, we only need half of that because we only want this bottom piece here. So that's the reason we get 1/2 base times height. Trapezoid's a little bit harder to see because they have different bases. So the bases are the parallel lines. So these two parallel lines. That's going to be my base. Doesn't matter which one's B1 or B2, but those are my bases. And the height, just like I said it was in the parallelogram, is not the slanty lines. It's the line that comes straight down here. It's actually the perpendicular bisector. So that is my height. What you don't want to use, and I see people do this, don't use the slanty lines. We're not going to use these. We didn't use it up here with the parallelogram. Don't use it for the trapezoid. So the trapezoid, this is one we have to find a little bit harder. So its area is, again, that 1/2 times the height. But this time we're going to have to multiply that by B1 plus B2. So we're going to add those together. So 1/2 times h times the sum of these bases. So that one you might have to work it a little bit. The circle, the area is pi r squared. Do not confuse this with our circumference because we're going to need to know both of these. So the area is, the area is equal to pi r squared. And normally if we were in class, I'd make you sit through a whole reason why this is, but most of the time people don't care too much. I just think it's really neat that we can prove what it is. But basically, if you take a circle and you really think about a pizza and you cut it into triangles, because that's normally how we eat a pizza. If you cut it into a whole bunch of tiny, tiny, tiny little triangles and you add all those areas up, that's how we found out the area of a circle. We knew that the circumference was 2 pi r. So the circumference is 2 pi r. And we know that they're tiny little triangles. And we multiply those together and we got this area. Again, you probably don't care a whole bunch. It's going to be hard to show on here, so I'll skip that. But don't confuse it with the circumference, which is 2 pi r. Keep these two things separate. The circumference measures the outside all the way around, like if I were going to put a fence around a swimming pool. The area is actually how much land that swimming pool would take up. So make sure to keep those separate in your head.